Today's topic is arc flash. This is the last class or last content containing class for this year. We ended up with a couple extra time slots in our schedule simply because all the tests and quizzes that we were supposed to done in class, you have done them online, so we ended up with some extra time. That's okay. Right, so we're going to have a couple of YouTube videos in the beginning. However, they will not appear on the recorded posted content, simply because I don't want to violate any copyrights. However, I can show them in class normally. But the links to those YouTube videos will appear as suggested links, suggested helping links when it comes to the posted notes in the class portal. So when you download that, you will be able to see those links. All right. Okay. Right. Let's see what we can do first. Imagine an electric train or a streetcar, but train is even better because you can see that there's a couple of rails and there's a train going with so many cars, a couple of locomotives, maybe 2 or 3 in some cases, and the power is grabbed from that one cable that basically is the traction cable. It's that overhead cable that is over the tracks. That cable is capable of supplying enough power to get that train moving. And if you ever rode an electric train, which I have multiple times when I was in Europe, it's actually quite amazing because sometimes when the train driver was not careful, when he moved that train too fast at once, then you would actually get bolted into the seat a little bit. So the power is there in that one cable that hangs over the railroad tracks. So just imagine all that power there. Now, normally you can't see that. If the train is not there, you can see the wire, and there is clouds, trees, birds are flying, everything is nice and peaceful, and you see some sort of a wire that's hanging over the tracks, and you don't see the amount of power that thing is actually capable of giving. All right, so that's why we're going to talk about the arc flash. Now, when it comes to electricity, electrical field or field of electricity, I consider one of the most dangerous fields to work with. And why is it so dangerous? Well, when you are in a plant or a factory and you can see some heavy machinery running, you can actually physically see the machinery, you can see the power, you can be aware of that. Now, the electricity is quiet, right? Nothing happens until something happens, and you just need to be aware of that, because even though you don't see the potential there, the potential is tremendous. Okay? So that's why the purpose of this class is to give you some sort of awareness when it comes to this type of risks or dangers. When it comes to the arc flash, you are going to get, whenever you're going to be employed, you're going to get periodical training when it comes to arc flash, and you're going to be trained and certified depending on the danger severity that you will be working with. So this is not a certification kind of a class. This is an awareness. Things do change every so often. So whenever you get a job in the electrical field, some of the details actually might change, and I will show you how the details have changed, because I'll give you some boundaries or arc flash boundaries examples from the 2015 and then from 2019 changes. Okay, so yes, they do change. By the time you get employed and be fully capable of working with that, some of the details might change, but the basic principle of the danger that is involved when it comes to electricity, that is going to be, that is going to remain the same. So awareness is well, is the word of today. Okay, all right. So now, first video that I'm going to show you, which is not going to appear in the recorded session, is this electric train. There's a lot of weight and mass to be moved, and it's being moved so easy. Now, when it comes to the power, when you get a chance, can you please respond to my email regards? I thought I did, but I'm going to look for your email, and I'll see if I can respond. Yeah, okay. Okay, did somebody get my ears? Was it too loud, the sound from the YouTube thing? Maybe it was. Do we have another test? Yes, we're going to have a quiz, and we're going to have a test. This is week 11, so week 12 and 13, you're going to get a quiz and a test during the last week. There is no final exam, okay? So, where were we? Okay, now can you imagine if you're standing in front of some electrical circuitry that is capable of supplying a tremendous amount of power, and something goes wrong, and this whole power basically blows up right in front of you. That's something to be aware of, okay? And there are rules and regulations and procedures set for us to be safe, or reasonably safe, when working with electricity. Okay, so let's get to another video here. Yeah, you vaporize. Pretty much it. Okay. Now, protect your ears, because some of those YouTube videos are going to be a little bit louder and some of them quieter. I have no control over that. So this is an example of an arc flash caused by a tree branch falling on a couple of wires. Okay, let me just turn off the sound from that so we don't get accidental sound leakage from that. Okay, I'm going to close those videos just so they don't sit through, and queue up our PowerPoint here. So now, obviously, we have seen the power of and the potential of what electricity can do. So yes, the awareness has to be brought to you. Now, as I said, this is after watching these videos, which is not going to be seen on the recorded posted video, but it will be available on the downloaded PDF posted notes. As I said, you will, as you go along, when you get hired, you will be additionally trained and certified depending on where you work and what you have to do. Okay. Arc flash. I'm getting a bomb suit. No, that bomb suit is not going to help you with that. But there are certain type of clothing that are to be used when it comes to working with electricity in some cases. All right, arc flash here. There are a couple of not so pretty pictures that represent some sort of arc flash situations here. Now, these are those two videos links, the video links, except for the train one. Now, let's get some definitions out of the way here. Arc flash is, what's arc flash? An arc flash is an explosion caused by the release of energy generated by an electric arc. What's an electric arc? An electric arc is basically a jump of the electron flow between two conductive materials. And is it always unwanted? Well, sometimes it is controllably wanted, just like some of the explosions are not unwanted. Some of the most wanted explosion is inside the cylinder of an engine in your car. It's a bunch of explosions that are making the car run. So do we use arc flash to our advantage sometimes? Yes. For example, welding. Okay, but for the most part, when it comes to electricity, when it's not supposed to happen, then of course it is unwanted, and usually it's pretty much dangerous. Okay, all right. So let's keep going with our causes of the arc flash. Include there could be dust and impurities and contamination, corrosion, and animals. Animals are a big one because if the casing is not closed properly and if there's some damage, some small animals can crawl in to some electrical equipment, and of course to enough voltage and enough power that is there, that little cat or a rat or a mouse or whatever it is, it can actually short a couple of terminals and causing an arc flash. Right? Of course, dust and water and impurities. Dust and water is a big one. Water, of course, conducts. So if water gets into some equipment, it can also, because water is a conductor up to some point, it can cause arc flash. Now, as far as dust and impurities, well, electrical equipment is supposed to be maintained and clean all the time, depending on the environment. Some factories and plants will have to have more rigorous cleaning procedures when it comes to electrical panels or whatever electrical equipment, simply because when you get the dust between two conductive points, and then the dust eventually combines with moisture, it becomes conductive, and at some point there could be electricity flow right through it. Right? So again, dust, water, impurities, contamination, corrosion, and animals, discharge from accidental contact, dropped or improper tools. Remember when we talked about the multimeters? There are different categories of meters that are supposed to be applied while measuring certain type of electrical equipment. If you have a meter that is not suitable, not designed to measure certain higher power equipment, that meter can actually explode in your hands, causing also arc flash. Okay? So there's a reason why there are categories of certain type of meters. Discharge from, okay, over voltages across narrow gaps. Air is a pretty good insulator. However, if you have couple of terminals that are highly charged, you bring them closer together, you're going to get a spark jumping across those two terminals. Usually it's unwanted. However, do we have situations that it's wanted? Again, welding is one. The other thing would be the spark plug in your engine. You get the spark jumping right through, and it's through the air. So air has extremely high resistance. However, the air resistance is not infinite. It has resistance. That means electricity can flow through it. You just have to push enough with enough strength. All right. Okay. Let's see here. Failure of insulating materials. Well, that's obvious. Loose connections can cause arc flash. Equipment failure, of course. And here's a big one. Workers assume that electrical equipment is de-energized. You're going to, as you go along and you get yourself hired in certain companies, you're going to have certain procedures to follow, making sure that the electrical equipment is turned off. One of the most common practice is do not assume anything. There are certain lockouts in electrical panels that you're going to use. So basically, you open the panel, you turn the breaker off, and then you close it and you put a lock on it with a whatever the regulations of the law of the land requires you to put the note. But even better is basically if you don't see where the electrical panel, maybe it's behind the corner or somewhere else. Basically, you put a person there standing. So while you're working, this thing is supposed to be turned off. While you're working around the corner, then that person makes sure that nobody walks up to the panel and says, "Oh, how come there is no lights here? You know, oh, there's a circuit breaker that's turned off. Oh, let's turn it on." And then it kind of gives you a little bit of a jolt, sometimes more than less. Okay, so so that's here the causes. Consequences. These are not tattoos. Okay. Consequences of an arc flash can include electric shock, severe burns, blindness, deafness, shrapnel wounds, long blast injuries, and the biggest one of them all is basically, it can cause death. Okay. So this would be the causes and the consequences. I don't think I need to explain any of that, although there will be some details here. Now, arc flash blast effects. Okay, the big one is sound. I'm looking at the so anyone know how to unsee an image? There's that chat thing here. Well, it's better for you to see that than experience that. Okay, so arc flash blast effects. Sound. Arc blast at 2 feet can be as loud as 145 decibels. Okay. Now, jet engine at 200 feet can cause sound volume of 132 decibels. Pain threshold to a human ear is 130 decibels, so that the sound that is caused by the arc flash can be quite unpleasant and damaging. Okay. Now, does anybody know? Like, for example, if you're at a concert pre-COVID or maybe after COVID, who knows how many years from now, maybe soon, what is the sort of legal limit for the sound to be? What's the level of the sound at the audience before it becomes illegal? And actually, your concert could be shut down. It is about between 85 and 95 decibels. Right? And that's actually pretty loud. So a little bit less than 100 dBs. Okay. Now, heat. Arc flash can cause also heat. Arc flash can be up to 20,000 degrees Celsius, which would be about 35,000 degrees Fahrenheit. Now, just as a comparison, the sun at the surface is about 5,600 degrees Celsius or 10,000 degrees Fahrenheit. All right, so arc flash can be deadly just from the temperature. Now it's a momentary. It could last few seconds, but it's enough to kill you. All right. It's for both inside and outside concerts. Is that both for inside and outside concerts? Well, as far as the volume, basically at the audience, where the audience is sitting. Okay, is where the audience is placed. That's William Smith. Okay, yeah. Okay, let's keep going here. Arc flash blast effects. Arc flash. What can the arc flash do? Well, it can throw a worker off the ladder, throw a worker into nearby walls of equipment. So just from you being thrown into a wall, you can experience a severe damage. What did I write here? 1,400 kilograms per square meter or 2,000 pounds per square foot of pressure on the body can cause. You can get a concussion. You can get collapsed lungs. That's not a good thing because we use those for breathing. Now you can get severe internal injuries. Also, projectiles can be thrown at you. So basically, it's just like a bullet. Projectiles caused by arc blast can travel. Projectiles caused by the arc blast travel at speeds greater than 1,600 kilometers per hour. That's well, that's quite comparable, if not more, to a bullet that comes out of a rifle. Right? So if there's a bolt comes at you at that speed, that thing is going to go inside you. Okay, and trust me, you will not like it. There are certain there's rules and regulations that are standardized when it comes to arc flash. So Canadian Standards Association, Canadian Electrical Code, Occupational Health and Safety Act, U.S. National Fire Protection Association, okay, Institute of Electronics and Electronics Engineers. These are just some of the institutions that do have content that deals with the arc flash. As I said, you will be trained once you get hired, and you'll be trained and retrained when it comes to so you can be trained and certified when it comes to arc dealing with arc flash, depending on what you do. All right. Also CSA standard. The CSA also contains content that deals with the arc flash. Now, CSA just a some content I'm going to cite here. CSA standard Z462 covers, okay, so there's electrical safety program, arc flash hazard analysis, arc flash protection boundaries, fault current calculations, arc clearing times, incident energy exposure, and required personal protective equipment that has to do with working on electricity, okay? When it comes to dealing with with electricity, you are bound legally to make things safe. You need to have, basically, it's just like, what can I compare this to? Working with explosives. High power electricity can cause explosions. It's just like working with a bomb. So you need to have some sort of training and licensing when you're working with that, because a lot of the equipment is being placed around where people walk. There will be transformers placed on the utility poles underneath which people walk. There will be transformers placed on the ground around which people walk, and sometimes people will come up and touch that because they don't know what that is. There are some legal obligations that I'm looking at the chat line here. What should I eat? I don't know. Okay. All right. So let's just say I just analyze some of the legal content here. Bill C45 is a federal legislation that amends the Canadian Criminal Code. So okay, so this is Canadian Criminal Code is involved here. Okay, Bill C45 became a law on March 31st, 2004, and is now the new section 217 blah 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 in the Criminal Code, which reads, oops, here, 217.1, everyone who undertakes or has the authority to direct how another person does work or performs a task is under legal duty to take reasonable steps to prevent bodily harm to that person or any other person arising from that work or task. So basically what this means, if you're working on the if you're working on certain equipment, or if somebody works for you, you hire someone to work on the equipment, you're under a legal obligation that this thing has to be safe. The bill established new legal duties for workplace health and safety and imposes serious penalties for violations that result in injuries or death. It also establishes rules for attributing criminal liability to organizations, including corporations, for the acts of the representatives, and also creates a legal duty for persons directing work to take reasonable steps to ensure that the safety of the workers and the public. So It's not just the content that deals with the arc flash. It's not just suggestion. It's actually part of the law. Okay? All right. Canadian Electrical Code CEC rules: electrical equipment such as switchboards, panel boards, industrial control panels, meter socket enclosures, and motor control centers that are installed in other than dwelling units. What's a dwelling unit? It's a house or apartment, where people live. So places other than dwelling units would be commercial space. Commercial space or public space are likely to require examination, adjustment, servicing, and maintenance, while energized should be field marked to warn persons of potential electric shock or arc flash hazards. The making referred to the sub-rule blah 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 shall be located on the clearly visible. So basically what this one says, anything that can cause arc flash that is in places other than your household living space, which is a public space or industrial equipment, it should be labeled clearly that the person who walks, as long as you can read, you should be able to figure out that you are kind of close to something that is dangerous. You do not have to have any kind of training in order to know that this is dangerous. All right, hazard risk category levels. All right, CSA Z462 has identified 4 hazardous risk category levels, which are numbered by severity from 1 to 4. All right, I'm pressing the button and nothing happens. All right. Uh-oh. Okay, I think we have, let me just see here. All right, we're just gonna have to, seems like the, all right, now we get this content here. Somehow the PowerPoint did not want to display it. So, okay, hazard risk category level. CSA Z604 hazard risks. Now, hazard risk category is the level of arc flash protection clothing that you must wear to protect against a minimum level of incident energy measured in calories per centimeter squared. Well, why do we have different categories, excuse me, to begin with? Well, here's that sort of like a catch-22 thing. Normally, if you want to protect anybody from anything, you would just basically put a spacesuit on them, as heavy and as protective as possible, and put them to work. Now, the problem is that sometimes if you put too much clothing on, or if you overprotect yourself, you won't be able to even do the work because you're just going to boil in those clothes, right? So there's that fine balance between how protected you want to be and how is that actually preventing you from actually doing the work. And if it prevents you from doing your work properly, it actually creates another kind of a danger level here. Okay, now here. Meaning that electrical equipment, depending upon the energy delivery capability under the fault conditions, can cause an explosion or arc of a certain level, measured in calories per centimeter squared. So the categories are classified according to the type of equipment and the amount of energy that the equipment can deliver under a total fault. So we you got a full short between two terminals. What's the current capability, or what's the power capability under a dead short? So there's a certain level of classifications as far as protecting you from that. The explosion can deliver a certain amount of heat. So the heat is the key here. The explosion can deliver a certain amount of heat to a certain distance. Each level is related to a certain amount of flame resistance measured in calories per centimeter squared or per square centimeter. Okay. Let's see if we can bring that on the full screen here. Now, what is a calorie? A calorie is the amount of heat needed to rise the temperature of 1 gram of water by 1 degree Celsius. Okay. It's a thermal energy is measured in calories per centimeter squared or square centimeter. Now, 1.2 calories per centimeter squared is just like if you were holding your finger in the blue part of the flame for 1 second of a cigarette lighter. Okay, so now we're going to stop here as the first part of this class. Tomorrow we're going to finish up. We're going to touch up on the boundaries. We have one quiz and one test to do. We're going to utilize that time for the test. I'm going to make sure that I email that to everybody and I put it on the announcements. You're not going to have a week to do the test and the quiz. You're going to have the class time to complete the quiz and the test, and I'm going to give you some extra time to complete that. So if it's like an hour class, I'm going to give you maybe 2 hours. So it's a double time to complete this, and it is going to be online as well as it was. Okay? But this time we're going to do it like everybody else does during the class time. Okay. All right. I'm still marking the assignments. It is going as it is going. All right. Okay. So this was, let me just set up my transitions here. I don't like those clean cuts. There we go. This was the last slide that we have talked about during the last session. I am going to combine these two sessions into one timeline. So instead of 2 videos, you're going to have 1 video posted on YouTube from yesterday and from today. Okay. All right. So that was the last slide here. We discussed what a calorie is. A calorie is an amount of heat needed. It's basically a measurement, a unit that measures heat or energy. Now, calorie is the amount of heat needed to rise the temperature of 1 gram of water by 1 degree Celsius. In order to warm up 1 gram of water by 1 degrees, we need 1 calorie of energy. That's a thermal energy measured in calories per centimeter squared or per squared centimeter. And then here's a bit of a visual. If you're holding a cigarette lighter in the blue flame, if you put your finger in the blue part of the flame of the cigarette lighter, which is basically right in the flame, for 1 second, you're going to transfer 1 calorie into your finger, and it is going to be measured in the volume of when you say ouch. Not really, but you are going to say ouch if you do that. I was thinking, just can you burn calories like this? Well, can I burn calories drinking cold coffee? Well, maybe it's a research material. I know celery has negative calories, and as you can tell, I don't eat much celery. Okay. All right, let's skip to the next slide. It's going to be a short lesson today. Now, the reason why I gave you the calorie visual is because we're going to talk about, we're going to utilize the calories in the next few slides. So I thought that maybe it would be a good idea for you to know what we're talking about. Okay? All right, so personal protective equipment when it comes to arc flash. Remember what I said yesterday about when I talked about the personal protective, or PPE, personal protective equipment, when it comes to electrical work to protect you as much as possible from the arc flash. Now here's the, as I said, catch-22. How much clothes do you want to put on, and you can, so you can still perform your work. You know? So I think it's the proper balance of the amount of clothes you're wearing and the protection that it will give you versus your ability to do your work. Because if you just you know, if you put 17 layers of space suit on you, you won't be able to move, and you won't be able to perform your task, and you won't be able to perform your task comfortably, which is going to add to your job. You're going to make your job more dangerous just by wearing the clothes you're wearing, okay? Because you won't be able to move properly. All right. Okay. PPE requirements for arc flash. Okay, so here we have the 4 categories of hazards or risks. Okay, so and then there's clothing description, and then the minimum required arc rating, and this is the PPE, and the rating is calories per centimeter squared. Okay, so here is the category 1 for the PPE. Now it's arc-rated, flame-resistant shirt, flame-resistant pants, or flame-resistant coverall, 1 layer. All right. So flame-resistant, I don't need to explain. It's supposed to withstand a certain amount of flame. Okay, so it should not catch fire. But then there is that arc-rated terminology. So what we're going to do here, I'm just going to jump into the definitions here. PPE, designed to protect arc flash resistant, called arc rated. Okay, clothing. Arc rated clothing has been tested against exposure to an electric arc, and its arc rating is expressed as a number. Okay, what's the number that we're going to talk about? The number is, let's say, 4. So it'll be a 4 calories per centimeter squared. Okay, 8 calories per centimeter squared, and so on. Okay, it's supposed to withstand that. Okay, so I'm just going to bring it to the bigger screen. All right. So now a hazard risk category number 1. So we have covered that. Category 2, arc rated flame resistant shirt and flame resistant pants and coverall, 1 or 2 layers, and it's supposed to withstand 8 calories per centimeter squared. Okay? Then we're talking about category 3, arc-rated flame-resistant shirt and flame-resistant pants or coverall, and arc flash suit, selected so that the system arc rating meets the requirement minimum. The minimum requirement. The required minimum 2 or 3 layers, and that is supposed to withstand 25 calories per centimeter squared. Okay? Then there's category 4, arc-rated flame-resistant shirt and flame-resistant pants or flame-resistant coverall, and arc flash suit, selected so that the system arc rating meets the required minimum 3 layers or more. Okay, and that is supposed to withstand 40 calories per centimeter square. So that's imagine holding 40 cigarette lighters on your finger for 1 second. It's going to give you a little bit of a more burn than just one. Okay, well, 40 times more than one. Okay? All right. Astm standards, some definitions, because we're going to talk about that in the next slides. What is the meaning of Astm standards? Okay, the group developed as a standard for the steel and used to fabricate rails, originally called American Society for Testing Materials. It became American Society for Testing and Materials, and then it changed to ASTM International. Okay, in 2001, and added the tagline standards worldwide. So that's the ASTM standards that we're talking about. Okay? It's an institution that kind of controls procedures. Now, personal protective equipment requirements, PPE requirements while working in arc flash risk environment. Okay. Now, what do we have here? The requirements. The PPE should limit the incident energy level to arc flash to 1.2 calories per centimeter squared against the worker's chest. Okay, so then look for labels that says 1506 approval by ASTM F1506, arc rating of the garment. So arc rating, remember when we did the, it's supposed to have the arc rating. These are the numbers right here, 4A25. So that it should be included in that in the description of that somewhere on the tag. We're going to go back here. Then all materials and garments should be flame resistant rated, which means thread, buttons, insulations, zippers, etc. Everything should be flame resistant. We have seen the pictures of what arc flash does. We want to be protected against as much as possible. Now, by saying this, I'm going to make a statement. The PPE is not going to there's no guarantee that the PPE is going to save you from that. We don't live in the ideal world. Of course, you should take every precaution that the arc flash is not going to happen. However, if for some reason something happens, at least you have some sort of a chance. Plus, it's the law that you need to wear that. Okay? Is it safe to say it is better than nothing? Maybe that's the idea here, okay? But there's no guarantees that if the arc flash is large enough, there's nothing that is going to save you if you're standing close enough. Just like wearing the bomb suit by the military personnel. Okay. And ASTM stands for, we just covered that in the previous slide, American Society for Testing and Materials. Okay. Now, this is what the PPE looks like, category 1, 2, 3, and 4. All right. So you will be able to, this PDF version of this presentation is going to be on the class portal in a few minutes. After the class is done, you'll be able to download and you'll be able to see this thing in more detail. This is basically what what the PPE looks like according to the categories here. Okay, as you can see, the category 1 is the easiest one, and the category 4 is the hardest one. The PPE is supposed to protect you against a more severe arc flash than category 1. So that's how these things are classified. Okay. Tasks with potential. Tasks with potential for arc flash. Well, operating a switch or a circuit breaker. Remember when, well, I wonder if you were shown or not during the first lab orientation. Sometimes when I do the labs, I walk you around the room and I show you the circuit breaker, and I show you how we're supposed to operate the turn back on the circuit breaker. And basically what I do is I use my weaker hand, which is my left hand. Now this is a mirror image, so I'm going to pretend this is my left hand, which looks like in a mirror image. So what I will do, because my right hand would be the dominant hand, so I use my right hand the most, and my left hand is the less dominant, with the weaker hand. So if I lose, if I have a choice to which one I'm going to get compromised, of course I'm going to get my not dominant hand. So when I'm going to flip the circuit breaker back on, I'm going to open the hinge of the circuit panel, and then I'm going to make sure that my face is away from that and it's separated by the hinge. And when I flip the circuit, I'm just going to do it with my weaker hand. That's how I'm going to operate the circuit breaker. Okay, so well, circuit breaker can closing a circuit breaker can result in an arc flash if there is something wrong with the circuit that you're operating. Anytime, I'm going to just give you a free advice outside of the scope of this thing here, but whenever the circuit breaker trips, please find the reason first instead of just going and flipping it back on. Because if you don't find the reason, if you're not sure why the circuit breaker has tripped, you might put yourself in a dangerous situation, and as for example, an arc flash. Okay, because there could be some short, some machinery could be malfunctioning, or some wires could be shorted. You're going to flip the circuit breaker back on, and on contact, that's where the arc flash could happen. Of course, there are circuit breakers that are rated for different power rating. Okay, so now if you're talking a circuit breaker or a fuse that is operating on one little 5-volt power supply, it might cause an arc flash that is going to basically burst something in your face, but you're going to still be alive. But if there is 10 kilowatt or something like that, and you flip that thing on, the arc crash can be quite severe. Okay. All right. So inserting or removing a circuit breaker or a fuse, you can see this. This gentleman right here, he is basically operating or replacing the fuses or circuit breakers. Okay? So that can cause an arc flash. Opening or closing enclosure door. Okay? Operating the enclosure door, most of them opening. It's okay. So here's this gentleman here is opening the enclosure door that's to gain access to electrical circuitry. That can cause an arc flash because there could be some elements that could detach and fall into some parts, and that could cause an arc flash. Okay, so there is a potential for arc flash. Removing a cover, hinged or bolted. Okay, so removing a cover and testing for voltage. So opening enclosure door or removing a cover. These two pretty much are related. Okay. Now testing for voltage. This gentleman on the left here, he's using a stick to measure measure voltages across some terminals. Then that can also result in an arc flash. Okay? So these are just some common examples of the risk for arc flash. Okay? Now, hinged or bolted covers. Well, this would be a hinged cover. This would be a bolted cover. Right? Now over here, it will be hinged and bolted because here's a hinge cover and there's a bigger cover that's with the electrical panel. There's a hinged cover and there is a bigger one that's bolted. Okay, so that's what I mean by saying operating hinged and bolted covers. Okay. Now, we're going to take a look at some boundaries. Now, I'm going to show you two versions of the boundaries because you're going to see still, you might encounter, you shouldn't, but you might encounter some of the old previous boundary classification. But now we have reduced some, and I'm going to show you what the differences are. There's not much of a difference, but still there is some. So when it comes to arc flash or electrical equipment that can cause arc flash, we do have something that's called that we do have boundaries. Now, if somebody asks me what the distance is between the boundaries here that you can stand, basically it says as close. It determines how close can you stand to the electrical equipment that if the arc flash happens, you're going to be put in a certain level of danger. Now, the distance can vary because the equipment power rating and the possibility or the capability of causing a certain type of strength of arc flash can also vary. So in plants or commercial environment, you're going to see those boundaries of a different distance depending on the strength of the equipment that we're using, okay? So this is the previous boundary classification. They are called approach boundaries, okay? So we have limited approach, restricted approach, and exposed approach, and then there's arc flash protection is the gray area here. So these are the 2015 boundary areas. Okay, now let's just examine them just a little bit, and we're going to talk about the differences from what it was and what it is now. Okay. All right, so let's examine the first one here, flash protection boundary. This is the gray. You see, I just put different colors on the names of the boundaries, and the colors do correspond to this. So this is the gray area here, flash protection boundary. Okay, PPE must be worn to prevent second-degree or greater burns if exposed to an arc flash. So if you're standing there without PPE, as close, if you're standing in the gray boundary from 2015 rating, if there was an arc flash, you most likely would end up with a second-degree burns, okay, if you have nothing, no PPE. So this is the outmost boundary, furthest away from the energy source. Now, unqualified person can approach unaccompanied. Okay, so if you're not qualified there, you can still be that close to the equipment within the gray area. Okay, now unqualified person might only cross this boundary accompanied by a qualified worker. So you should be with someone who knows what they're doing if you want to cross that boundary. So if you want to get into this area here, into the gray area. Okay? Should an arc flash occur, the person exposed to the blast would be subjected to the heat generated by the arc flash, resulting in a second-degree burn, which would be 1.2 calories per square centimeter. Okay, so this was we just saw the gray area here, which will be the flash protection boundary. Okay. So that's the distance, right? Now, mind you, again, I'm going to say this is from 2015. Now, the other one would be the limited approach, only qualified persons within this boundary, okay? Unqualified persons might enter when continuously accompanied by a qualified worker, appropriate level PPE and what's this thing here? Appropriate level PPE and trained for the task. Okay, so so we're getting to closer to the severity, greater severity of the arc flash results here. Now, next, so this was the green area right here. This would be the limited approach. Okay. Now, let's go to the yellow, because restricted approach boundary, only a qualified person, a worker, appropriate PPE level, properly trained for the task to be performed. This boundary is restricted to unqualified personnel. So if you're not qualified to do the work, you have no business being there, okay? Or anybody. So exposed energized electrical conductors or parts, 50 volts or more. No? 50 volts or more. What do we have? What do we have at our wall? we have 110 volts. Does it mean that you should not be able to approach the outlet that's in the wall to plug your TV? No, you should still be okay, because it's not the voltage, but it's the voltage can also, you're talking about the current capability as well. So 50 volts or more is going to, we're going into the danger level right now, but we're talking about some high power equipment. Okay? Required approved requires, okay, so this area, yellow area here, it requires approved work permit with a written plan of the task being performed. So in other words, okay, the written plan should include well-defined procedures to prevent exposure to shock or hazards. So in other words, what this says here is that if you're getting this close to the equipment, to the energy source, you should not be there this close unless you actually have a purpose or a business in going there. Otherwise, there is no reason for you to be there or anybody to be there because of the risk of an arc flash. All right, now let's move to the red area here. And this is again 2015 boundary areas now replaced with the 2019 version. And we're going to take a look at the next set of slides. Now, prohibited approach boundary, energized life part, energized life part. This is considered to be the same as making contact with the live part. Okay, so when you're this close here, it's basically as if you were touching the live wires. Distance varies from direct contact to several feet, depending on the voltage or the power that the arc flash can deliver. So that was the 2015. I just want you to know that those boundaries existed, and maybe in some cases you're going to still see some literature or some documentations which you shouldn't. However, if you see that, I just want you to know that this is what it means. Now, the new 2019 boundaries are as such. So you see, we have eliminated one here. See, restricted space or restricted boundary. You see that here? Restricted approach and restricted energized. So these are considered as one. Okay, like these two here, these two were combined into one. Probably, you know, it does make sense because if you're this close, if you're this close and the arc flash happened, there's probably going to be not much difference of the severity of the shock that you're going to receive from that. All right, so they decided to change this approach and boundaries, and by saying they, it's the common they, whoever that they are. Okay, now so we have here approach boundaries instead of 1, 2, 3, 4. What do we have now? 1, 2, 3 boundaries. Okay, because the two closest ones were combined into one. All right, so approach boundaries. Okay, arc flash boundary, which is the furthest one. Similar thing, the arc flash boundary or restricted approach boundary changes depending on the potential of the arc flash hazard, which is what we just talked about in the first slide of the 2015 boundaries. The arc flash boundary is calculated to 1.2 calories per centimeter squared of incident energy. That's the distance where the worker without appropriate PPE would receive a second-degree burn. Just because you are on the furthest boundary doesn't mean you will not get hurt should the arc flash happen. You're still going to get hurt, but not as severely as if you were standing right at the energy source. Second-degree burn is also not a very pleasant thing to have. Okay? Don't do this at home, kids. All right, so sometimes this boundary is the furthest one from the, okay, so sometimes well, sometimes, here's the word sometimes. it's going to make sense to you when we talk about the next slide. So sometimes this boundary is the furthest one from the exposed equipment. Other times the limited approach boundary is the furthest out. Okay, so here's the limited approach boundary. So when the arc flash boundary is the furthest away, it becomes the line that no one shall pass. No one should pass without training or PPE and PPE. If the limited approach boundary is the further out, then that should be treated as the line that no one should pass without training or PPE. Okay, so so the restrictions are a little bit more rigorous, and rightfully so. All right, now we get to the limited approach boundary, which is the kind of like a, I would say, amber area there. So that's this here. Here's the limited space, and here's the limited boundary. Okay, so here's the arc flash boundary, and here's the space. And then there's limited approach boundary, and here's the space, and so on. Moving towards the energized exposed equipment, you will find the limited approach boundary. Okay? So if you're going towards the equipment, next thing you're going to encounter is the limited approach boundary. Within this boundary, it is still possible to be exposed to a shock hazard. Okay, appropriate PPE should be worn by qualified workers in the limited space between the limited approach boundary and the restricted area boundary. So that's basically this here, limited space. Right? Non-qualified workers should stay outside of this boundary unless wearing a proper PPE and being escorted by a worker with specialized training. Right? So in this case here, you can see that the non-qualified person can come a little bit closer to that, as long as they are basically accompanied by a qualified person, and they should wear the PPE. Next here, restricted boundaries. So here is the last thing here, last boundary right here. It's just closest to the equipment, energy source. Restricted boundary, this area is the closest to live exposed equipment, is within the restricted boundary. Okay, in order to pass this boundary, you must be a qualified worker with a proper training and PPE. If you need to perform work on energized equipment, you might also need a work permit and documentation. So again, with this boundary right here, you should, if you're getting this close to the energy source, you should have a reason to be there. Okay, if you don't have a reason, if there's no need for you to be there, and if you don't have a work permit or the proper documentation of what you're actually supposed to do, if you're not supposed to be there, stay out. That's the rules of that. So okay, so this basically closes our lecture content. I'm still getting the assignments handed in. Somebody yesterday asked me if I saw their email. I forgot who it was. I'm going to look through all the emails because sometimes people were having troubles uploading the assignments. So if I don't see if I don't respond to your email by today, just send it to me again, okay, please. There were some emails that I had. Some people have attached files because there were some troubles online when as far as visibility of the assignment. Okay. Yeah, I was a little bit tougher on you when it comes to marking this assignment. There is a reason for that. You might be a little bit. Well, you might be unhappy with some of the marks you got. But if you take this thing the right way, you're going to thank me later for being tough on you when it comes to this. Okay? Now, this is a school. So if you do something wrong within the school environment, you might get some pointers, you might get some marks deducted. And the purpose of that is so you don't make the same mistakes when you go to the industry, because if you make those type of mistakes that you get the marks deducted for, you don't get marks at workplace. There is no marking. The way to evaluate you at work is sometimes you just have no job because of things that are being done wrong. Okay, so in school, doing things wrong might cost you marks. At work, if you do things wrong, it might cost you a job. All right. Well, thank God that the school is first and the work is second. Okay. All right. So I'm just going to repeat what I said in the beginning. The next week, I'm going to deploy I'm going to release the quiz, and that's going to be during the class time. And I'm going to give you extra time for that. Well, actually, basically, I'm going to give you twice as long for completing that. So you're not going to get a whole week to complete your quiz 2, and you are not going to have a whole week to complete the test 2. The quiz 2 is going to be next week during the class time, and the test 2 is going to be during the class time the week after that. And that's pretty much it for the evaluation plus the assignment. All right, that's pretty much it for today. You guys have happy Friday. Stay healthy and safe. And if you, again, as always, if you have any questions or concerns, by all means, email me and I'll do my best to respond to all of your emails now. Okay. Have a good one, and I will see you next time with the network cabling course. Okay. Have a good one.